Hello everyone, welcome back to my channel. In today's data structures class, we are going to learn stack concepts in detail. We will discuss LIFO principle, push operation, pop operation, peak operation, overflow, underflow, and applications of stack. These concepts are very important for UGC NET, TG set, and also semester exams and interviews. So watch the video completely and let us start today's session. Okay, so these are the concepts we need to discuss. So first we know about stack. What is stack? Stack is a linear data structure. Okay, what is the stack? Stack is a linear data structures. It follow which structure? It follows the LIFO principle. Okay, it follow LIFO principle. It stands for last in first out. LIFO means last in first out. So why that it is last in first out? The element inserted last will be removed first. So that's why the principle called LIFO. Okay, a stack is a linear data structures. It follow LIFO principle. LIFO means last in first out. This means the element inserted last into the stack will be removed first. Okay, so it is an ordered group of homogeneous items of elements. So what is the stack? It is an ordered group. So there is a sequence numbers is there in a stacks. So each and every elements are added and removed from the top of the stack. Only one end is there for the stack. There is no two ends. For example, if it is a stack, there are some elements are there in a stack. For example, A, B, and C. So this is nothing but what elements are added into the stack. And if you want to remove the elements also, we are removing from the top of the stack only. So if you want to add the element, if you want to remove the element, we will use only one end. Okay. It most recently added items are the top of the stack. Okay. So I will give one real time example. For example, a stack of cafeteria trays, how the trays are they are properly inserted. So there is a first they inserted the last one, then again they inserted this one, and again they inserted this one, and again they inserted this one. The inserted last one will be on the top of the cafeteria trays. So it is nothing but stack. For example, a stack of pennies, the coins are there. So last we inserted the item that we will see on the top of the list that we called as a stack. A stack of shoe boxes. First we arranged the three shoe boxes, one on the other, so top of another one. So first I inserted, for example, there are three shoe boxes are there, A, and this is B, and this is C. So first I inserted which shoe box? First I inserted A box. So whatever we inserted first, that goes to the last one. Whatever we inserted the last, that goes to the top one. Okay. So same example, the clothes. Okay. And that books are there and the stones are there, coins are there. Okay. Na? This is nothing but the stack. So first inserted element we will see on the last, and last inserted element we will see on the top. This is a real time example. You can take as a cafeteria trays, coin, the stack of pennies, the shelf of books, and the stack of neatly folded shirts and stack of books. Okay, I'm going to the next slide. Stack operations. There are two important operations are there for the stack, that is push and pop. Okay, if you want to insert any element in a stack, we will use which operation? We will use insert operation. Okay, if you want to insert any element in a stack, we will use push operation. Push is nothing but the insert elements in a stack. And if you want to remove any elements in a stack, we will use what? We will use pop operation. Pop is nothing but remove the element in a stack. And there is a peak option, is there peak, or we can call it as a top. Okay, peak or top. So it will display the top of the element is empty whenever the stack is empty, because nothing is there in a stack. There is no items in the stack. There is no items in, there is no elements in a stack. This is called as is empty. Now the stack is empty, so we can insert the element. So it is nothing but the full. For example, This is one stack A, B, C, D. So what is the size of the stack? The size of the stack is 4. Okay, so how many elements I can insert? I can insert only 4 elements, A, B, C, D. So if you want to insert the 5 number, is there any option is there? No, because the size is 4. So we cannot insert the new element. So it is nothing but the C. Whenever the stack is fulfilled completely, then we call as a is full. If nothing is there, there is no elements in a stack, then we will call it as a is empty. These are the main important operations are there in a stack. What is this? Push, pop, peek, is empty, and is full. Push is nothing but inserting the element. Pop is nothing but removing the element. Peek is nothing but the top of the element. Is empty means whenever the stack is inside the stack, nothing is there, then we call as is empty. And if the stack is full, we call as is full. Okay. So there is a representation of data structures is there. The technical diagram is there for the representation of stack data structure. So here this we call as one stack. Okay, this area we call as a stack. So here what we are doing, we are filling the elements are there. So that elements we call as a which element you are filling into the stack, that elements we call as a data element. Okay, so which principle we are following for the stack? Last in first out, LIFO. This we call as LIFO, last in first out. So what is the push operation? We already discussed. Push means inserting the element. This arrow is belongs to the inserting the element. So inserting which are the data element we are inserting the stack, and this is nothing but the this arrow is this side. Why? Because we are removing the element from the stack. This is nothing but pop, and we are inserting that. Inserting is nothing but we are adding the element into the stack, that is push. In there are 4 elements are there. We are removing one element in the stack, that is nothing but the pop. Okay. So we will discuss the push operation first, then we will go to the pop operation. Okay. The push operation one, push operation insert a new element into a stack. There is one example is that this is my stack element. There are 2 elements I taken 10 and 20. This is nothing but the stack, and I inserted what? First I inserted the 10 element, then I inserted a 20 element. It is nothing but the before the push operation I taken as one stack. So after I want to insert now, insert 30. I want to insert 30 into this stack. So if you want to insert which operation, we are using the push. So push of 30 means first, so the 30 will come with the top of the stack. Okay. It is so again one more example is there. First, if you inserted push A means first there is one empty stack is there. After performing of push A, what is our element? The A is inserted into the stack. After performing push B operation, so B is inserted on top of the A. After inserting push C, the C is inserted top of the B. And after, so here I am using which operation? For example, pop operation. Pop operation means it will remove which operation? It will remove A. If you remove A element, or if you remove B element, no. So it will not remove A, it will not remove B. The stack, every time the stack will remove only the top of the element. Here, first after inserting the push A, what is the top element? A. So after inserting the B, what is the top element? B. So now finally we inserted the T, C. Now what is our top element? C is our top element. Okay. So if you if you use the operation pop, which element will remove? The C element is removed here. So now what is the output? A and B. So again, if you want to use the pop operation, okay, again you use the pop operation. So now what is the top of element after removing the C? The B is the top of them. Now what is the answer? A. Okay, this we call as a push operation. Push operation is nothing but if you want to insert an element into the stack, we will use the push operation. So this we are trying to insert the push 3. This is the before push and this is the after push. Now pop operation. So what is the meaning of pop operation? Pop operation removes top element from the stack. So again I am taking the stack example 10. So how many elements are there in my stack? 3 elements. 10, 20 and 30. So this is nothing but the before the top example. So if I use the pop operation now, so first what is my stack? How many elements are there in my stack? There are three elements are there in my stack element. What are these three elements? 10, 20 and 30. Now I used which operation? Now I used pop operation. Then after pop operation, what is my output? The pop operation means what is our top of the element? My top element is nothing but one. The top element is 30. So definitely the top will be removed. So now after the pop, how is my stack is look like only two items are there, 10 and 10. 20. Okay, this is nothing but the push operation. It is very easy concept and also very important concept in a whole data structures. Queues and stacks are very important for all your competitive exams and your semester exams and TG set and UGC NET also. So again I will take one real time example here. I will explain. So the top of stack is accessible. Why we only adding the elements at the top? Why we only need to remove the elements at the top? So yeah, that we will see here. So if you arrange the books in one top of the one of the other on the top elements, there is a you are arranging the books in a sequence order one after other in a at the table. So what is the, so first I inserted this book, okay, and how many books I inserted? There are four books I inserted. So if you want to access these last book, is it easy to access? No. If I'm trying to remove this last book, maybe the books can fall down. Yes. So that is not a stack inaccessible. The bottom of stack element that is in a inaccessible state. So only the top of the stack we can easily accessible. Okay. Push a new book on top and pop a book from the top. So a stack have four books. This is a example. So are you understood? So again I'm telling there is some example is there a stack of four books. So the bottom of stack is in a inaccessible stage. So the top of the stack is only in a accessible stage. Push a new book on top and pop a new book and top. Okay. So now we'll discuss about peak operation. The peak operation is nothing but peak operation displays the top element without removing. The push operation it will add, pop operation it will remove, but peak operation it will not add an element, it will not remove an element, just it will show the result, it will display the result which element are there in a top. Okay, for example there is some elements are there 0, 10, 20, 30. These are the stack element. This is the positions. Okay na, a b, in a position 0 element is there, b position 10 is there, like that there are four elements are there. So what is the least element? The 0 is least element. So based on the LIFO principle, which element will remove first? At the top of the element, it will remove first. So we need to know about the top. Without knowing the top, we cannot remove the pop. We cannot use the pop operation. So here the top is also must and should to perform the pop operation. Okay. So top is equal to 30. So here the top is equal to 30. The top of the element we, in a stack we called as a peak operation. Okay, so if I give the syntax like this in my program, stack that peak. So what is our stack element here? The top element is 30. Okay, it is nothing but the peak operation. It will displace the only top of the element without removing it. Okay, now without removing, what is the top element? The top element is 30. Okay, so now if I remove 30 here using pop operation, if I remove 30, now what is my top of the element? My top of the element is 20. Okay, like this, it will work it. Moving to the next slide, there are different applications are there for the stack. The main applications are there in a stack: function calls, recursion, undo and redo operations, syntax parsing, and memory management. So function calls, when you will use function calls, it will manage and return address to the resume execution after the function call. The recursion, it will track the local variable and states that during nested recursive calls also we are using, and in redo and undo operations in a Photoshop or text editors we are using the stack, and syntax parsing also to validate the syntax in a programming and formal language we are using the stack, and memory management to support the dynamic memory allocation and deallocation we will call the stack. These are the applications are stack. Function calls in programming languages use the how we are using stack in a function calls in a programming language to the stack memory we are using. And one more example I will give you. So this is the important example for your stack. There is the two concepts that are there in a stack: back stack and forward stack. So when the back stack will work and when the forward stack will work, the real time example is there is a browser back and forward is there. So here we are taking the browser. For example, Google Chrome. If you take any browser example, here I am taking the browser example, Google Chrome. Okay. So there are two concepts, back stack and forward stack. The back stack stores the previously visited pages. In a web browser, you are visiting so many pages to do your work. So in a back stack, which result it is storing, the back stack stores the previously visited page. When you move to the new page, the current page is pushed into the back stack. Okay, na? So if you want to open, for example, this is first page and this is second page. Now you are in first page. So whenever you are moving the page to the second page, the first page will goes to what? The first page will goes to the back stack. Okay. So if you want to go back, we will use the back arrow. We are moving back to the previous one. Okay. Suppose you visited in a folder. Okay. You visited, there is some four folders are there, are four pages are there. Page A, page B, page C, and page D. So first I visited A page, next I visited B page, next I visited C page, and next I visited D page. So after performing the D, so what is our backstage? First I visited what? A, next I visited what? B, and next I visited what? C, then finally I visited what? 4. This is nothing but the backstack. So now what is our top element? My top element is D. So what is D? D is nothing but our current page. We are working in a D page, and these three are the previous pages. Okay. Then what is forward stack? The forward stack stores the pages that you moved back from. Okay. The current page is goes to the back stack. The page from forward stack is popped and displayed. So same example I will take here also. So the forward stack, the D, that is our current stack, right? So this will goes to the forward stack, and remaining A and B is there, right? That should be there in a back stack. A, B, and C. So why? Because I visited A, then I'm going to the B means first I there is some pages are there A, B, C. So first I visited A means that is in a current state. Then I visited B means immediately the A will goes to the back stack. And now currently I'm which page? Currently I'm in D page, so that is in a forward step. For example, if I moving goes to the E, then where is the D page will store? The D page will store in a back stack, and E page will store in a forward stack. Okay. So here one more example is that there are three websites at it. First you visited google.com, then you visited Facebook, and then you visited youtube.com. Like a recent tabs are there, like that recent tabs and how we are working in undo and redo operations based on the stack concept. Okay. So why stack is used here? Because the most recently visited page should come first when going back. Yes or no? So we are using the recently tab. How the recently tab will working? The most recently visited apps we are shown in the first, then we are going back. This perfectly matches the LIFO principle. Last in, first out. The last visited page is the first page written and remaining to then a back stage. Okay. Okay, and one more example is there. That is, one second. That is browser example, and one more example is there for the undo mechanism. We are using that in a text editor. So delete the word using the undo stack, and that is we are editing the current stack. That is one more example. And one more thing I forgot to tell, that is there is one two concepts are there. There are two conditions are there in a stack, that is overflow and underflow. So let me discuss the two concepts also, overflow and underflow here. So there is three elements are there in a stack, right? So first I are mentioning the size of the stack. So present my stack size is what? My stack size is 3. Okay. So how many elements I can insert? Only 3 elements I can insert. So use so let me take one more example. The stack size is 3. So how many elements I can insert? Only 3 elements I can insert. First I am using the operation. If you want to insert the elements, which operation we can use? We can use the push operation. So I am using the push 10. So push 10 means how my stack is look like. So 10 element is inserted into the stack. Again I am using the which operation to insert the element, push of 10. Sorry, push of 20. So here, the top of the 10, I am inserting the 10. Again, I am using the push operation. Okay, push of 30. So the 30 is inserted here. So again, I am using the push operation, push of 40. So can I inserted the 40 here? No. So why? Because my size is only 3. So if I want to insert the fourth element into the stack, there is no space in a stack. So that here we called as a overflow condition. The stack is overflow. Overflow. Whenever the stack is fully, again you are trying to insert a new element, then we called as a overflow condition. For example, there is one bucket and tap example where we on the tap and the water is filling to the bucket. So the bucket is fulfilled, and if again you are on the top, again you are on the tap, so the water will be goes down. So here that is nothing but the overflow condition. Okay. The same example we will use for the underflow condition. Did you get? Overflow is nothing but whenever the stack is full, again you are trying to insert a new element in a stack because there is no space. So how we can insert? We cannot insert the element, that we condition overflow. And again size 3. I am using the stack size is 3. So before how many elements we inserted? Up to 3 elements, 10, 20 and 30. So now I am performing which operation for these? Now I am performing the pop operation. So pop of 30 means, sorry, pop, just I am performing the pop. So here what is of my top element? My top of the stack element is 30. The top element is 30. So whenever use the operation pop, so which element it will remove? The 30 will be removed from the stack. Yes, the 30 is removed from the stack. So now how many elements are there in my stack? 10 and 20. So now again I am performing the pop operation. So now which element is removing? The 20, the top of the element 20 is removed. Again I am performing the pop operation. Again I am performing which operation? Pop operation. So now which element is removed? That element 10 is removed. So now is there any elements are there in my stack? There is no elements. Before there are 3 elements are there. Now I use the three pop operations. So all my three elements are removed. Again, I'm trying to use the pop operation. Now I'm using the pop operation. So now is there an element is there in our stack? No, nothing is there. So no elements are there in a stack. So if I perform the pop operation, it will remove any element? No, because nothing is there. So this condition we call underflow. This condition we call overflow. Whenever the stack is full, again we are trying to insert the new element we call overflow. When the stack is empty, but again we are using the pop operation, that condition we call as a underflow condition. Okay. So these are the important stack concepts in data structures. And remember one thing, stack will always follow LIFO principle. These concepts are very important for your UGC NET, TGCET and semester exams and interviews. I hope this class helped you understand stack concepts clearly. If you found this video useful, like, comment, share and subscribe to RDCS tutorials. Thank you everyone.